Welcome to part one of two videos looking at basic maths operators. I've split this video into part one and part two because even though arithmetic operators are quite trivial, there is also a lot of ground to cover, making for quite a big topic. So the objectives of this particular video are for you to be confident using the basic maths operators, which we also call arithmetic operators and BIDMAS, for you to be confident using comparison operators and to understand the Boolean data type in a bit more detail, to demonstrate the process for importing Python modules using math as an example, and to introduce UNICODE so that you can use symbols and operators as characters in formatting. So as usual, guys, just a reminder that Python resources are there to supplement your learning, the Python monster resources. The booklets and the videos, you may also find those useful for revision as well. So let's jump in and do some Python demos. So on the screen you will see a small table of arithmetic operators, at which point you'll be going, oh, that's okay because this stuff is easy. I've been doing most of it since primary school, which it is. Using Python operators to do basic maths is trivial once you get used to using the symbols that we use in Python, and you will get used to using them very quickly. The div and the mod terms at the bottom of the list I will cover in a separate video because these are really a small topic in their own right. So to make this a little bit more interesting, let me show you where we will end up with these Python demos on arithmetic operators. This is the output I want from doing some basic maths, so addition, subtraction, multiplication and divide, but also to be able to raise a number to the power of another number. So for example, 6 squared or 5 to the power of 4. I also want to include the maths feature you guys will be very familiar with, which is being able to find the square root of a number. Now, strictly speaking, the square root is not an arithmetic operator. It's actually called an inverse operator, but that's okay because it makes sense to include it here as well. Notice though that the classic symbol for divide, which is the line with a dot top and bottom, is used in the format for the output, but this symbol is not available on your keyboard. Likewise, I found a way to superscript the number 2 to show a number squared, and I found a way to represent the little tick symbol that you guys will recognize as the one that we use to show a square root in your math lessons. So the question is, how do we get access to characters that are not available on our keyboard? So this is something I'm going to cover in this video, mainly because it makes output a little bit more interesting and because you actually have access to thousands of characters that are not represented on your keyboard and which you can use in your Python code. Now that includes graphical representations and even emojis. So if you're in the mood, you can actually include a smiley face in your programs if you want to as well. I'm also keen for us to be using some of the learning that you've already done in class and from the previous videos. So for example, we're going to be casting to different data types, we're going to be using the concatenation of strings, and we're going to be using an example of a constant in our code as well as using variables. So on the screen is an example of very basic code that uses the basic arithmetic operators. We can use the traditional symbols for addition and subtraction because we have those on our keyboard. So those are the symbols, guys, that you will be very familiar with already for addition and subtraction. So in Python, we replace the cross or the X symbol that we normally use to designate multiplication, and we use the star or asterisk symbol, which is there. And we do that so that we don't confuse Python with it not knowing whether we mean multiplication or we're actually using the character X. We use the / for doing division, which also makes sense if you think about it because we use the same symbol in maths to show a fraction, and it's also used as part of the percentage symbol as well. Both of these uses of the / show that we have a number on top and a number on the bottom that we can do division on. Now at this moment, the output from doing these basic sums looks pretty dull. If you have a look on the right hand side, this is what we get. So let's move forward and have a look at the way that we can improve our code so that the formatting you saw earlier is the one that we include in our code and we produce the same types of results. Before we do that though, I need to backtrack because I've just realized I have forgotten to show you the Python syntax for raising one number to the power of another number. So you can see on the left hand side, the syntax that we use is we take the number, we put 2 stars after the number, and then afterwards we put the number that we're expressing the power of. So 12 to the power of 3 is expressed as 12 star star 3, so that's 12 cubed. If we want to do a number squared, then it's 12, for example, star star 2. So the way to remember this is to take out the expression to the power of and replace it with 2 stars. So 12 to the power of 3 means 12 star star 3, and 12 to the power of 2, or 12 squared, is 12 star star 2. Okay, so to use the square root function, we're starting at the top of the code, so I'm going to show you how we import libraries into the code. So to use the square root function, we need to import this from the Python math library, and you can see the syntax in the box in the code. Now this uses the American spelling, which is why we say math and not maths. So if you're wondering why it is that the maths that we've done up until now, we haven't had to import a math library in particular, and why with this particular function and others we do, well, this is all to do with keeping memory needed for Python programming to a minimum. So you want to avoid loading hundreds of functions that we may never use in a program into memory. Now you can see in the code that there are different options for importing external libraries and their functions, and these options have a different syntax. So basically what we can do is we can import by choosing one or more functions in a library by naming them specifically. So we just choose the particular functions that we want. Okay, or we can choose to import the whole library, in which case we do need to reference which functions we want to use in our code, because otherwise Python doesn't know we've imported the whole lot. So for this video, I'm loading the entire math library into Python, and you can see in the box the other options that I have a choice of. I've commented out because we're not going to use those other options in this example. The option that I have used says import math as MT. Okay, sometimes it's easier to use a short name instead of the actual library name. It just keeps the typing down to a minimum. Some library names have a much longer name than math. So my little nickname, to which I'm going to refer to the math library in my program, will be MT, which you can see here. So whenever you see MT in this code example, it's basically referring to the math library. All right, so bear that in mind for the moment. So I've just scrolled down the code so that you can see how we make use of the square root function in the math library to calculate the square root of 144. So it's in this print statement with a mathematical expression that needs to be evaluated, as you've seen before. So let's just get rid of that a second. Let's work from the inside out. This bit here, we're saying to Python, use the square root function, which is called sqrt, to find the square root of 144. You will find that square root function in the math library, to which I am giving it the name MT. Okay, so the syntax for this is MT dot. That tells Python that this particular function can be found in the math library, which I'm referring to with the nickname of MT. Now, it functions just the way it functions. It works just the way as any other Python function. You have a command word, which in this case is sqrt, which means square root, and then we have an open bracket and a close bracket where we put our data. So in this case, it's 144, obviously. Okay, well, of course, once we've got the square root of 144, and by the way, guys, it's often the case that maths functions in the math library are returned as float data types, not integer. So we will find probably, in fact, we can see here, if we look here, you can see where I've already used it and run the code. The returned value is 12.0, so that's a float data type. So having done that, we then need to ask Python to convert or cast the float data type, which is 12.0, into a string equivalent of 12.0 so that we can concatenate with the rest of our print statement, just as we have done in previous examples. So now I've scrolled back up, we're going to have a look at the Unicode equivalents of the characters that we want to be part of the formatting of our code. So I've just put a box around those at the moment. Again, I've assigned them to constants, and as you know, in Python we don't really have constants, we have variables. And actually you can see here in PyCharm it does actually confirm, it says that those variables, okay, are classed as variables with the symbol V. So there's no such thing as a symbol with a C in it for a constant. Okay, so this is the code that we use. Looks very much like a string, but this is here is the code that we use to generate the divide symbol. This is the code that we use to generate the subscript 2, which looks like when we do a value squared, like 6 squared. And this is the value, or the code that we use to generate that little tick symbol for the square root sign. So the question is, where do these little codes come from that I've assigned to my constants D, S and P? So the answer to this question is that, well, we actually use a special table called the Unicode table, and we'll look at character encoding like Unicode and ASCII later on in the course, in the theory section, and also using some more examples in future videos. Now the Unicode table is available on the internet. I'll show you that in a second. Okay, and a really good example of a website that you can use to find Unicode values. So just move it across to the recording window here and get rid of the boxes. There we go. Okay, so this website is called www.fileformat.info. So rather than copying down the entire URL, if you go onto Google and type in fileformat.info followed by Unicode, it should take you to this page or a very similar page. Okay, so what do we actually do then? Well, we type in, if I just scroll down, okay, we type in the name of the character that we're searching for, which is something I've already done here. So this is the next page that you would go to. So the Unicode character for the division sign, okay, and then when we scroll down, you will eventually find the Python code which will generate that particular character, which is here. And all you do is you literally copy it off the web page and then paste it into your code. Okay, so it's a really nice website with the Unicode table information in it. So the Unicode table is basically a lookup table where you can look up a particular character and it gives you a special code that you can use in your programming language. So we say that the Unicode for the division symbol is 00F7, which is this one here. Okay, so the Unicode code for the division symbol is 00F7. Likewise, we say that the Unicode code for the superscript of the number 2, okay, so that looks like to the power of 2, is 221A, and for that little square root tick symbol, okay, the Unicode code is 00B2. So what I've done in my code is that I've chosen to assign each of these codes to a constant. They're not really constants, they're variables, but you guys know that. Okay, what I have done is I put here, as I'm supposed to do, a comment in my code that basically says D, S and P are fixed values, or they should be treated as fixed values in the code. Okay, D, S and P, variables being treated as constants, in fact. Okay, so let's see how we actually use those constants that contain these strange codes in the formatting. Now we can treat these strange codes as string data types, although they're not quite strings. They look very much like strings because they've got the double quote in, but you can see that there's a special character on the outside of the quote. So they're sort of strings, or they behave like strings, we could say that. So let's page down and have a look at where we use them. I don't think there'll be any surprises, guys, because they're strings. So we essentially incorporate those characters into the concatenation that we do. So if we have a look on the right hand side, okay, the formatting that generates this, for example, 21 divided by 10 equals 21.04. okay, that line for the print statement is here. Okay, so if we start off on the right hand side, as we always do, we ask Python to evaluate the expression 210.4 divided by 10, so that's a float divided by an integer, okay, and that gives us 21.04. We then ask Python to cast it to a string data type so that we can concatenate it with the rest of our formatting, which it then does. Moving over to the left hand side, it basically concatenates 21 with D. That's the constant that's been assigned our peculiar string code that will generate the divide sign on the screen. Okay, and then on the end of the concatenation we have the 10 equals. Excuse me. So this here, which is our constant D, is evaluated by Python. It finds the code, it generates the divide sign, okay, actually on the screen, and it will do the same if we are generating data to a text file as well. Much the same with the square root. Okay, it's exactly the same process. We're just using obviously the different Unicode value. So you will remember that to find the square of a number, it is the number star star 2. Okay, so in this case 6 squared is 6 star star 2. We then asked Python to cast that to a string so that we can concatenate it in our print function, which is there. Okay, the rest of the string data type formatting is on the left here, and obviously P is interpreted by Python as the little 2 superscript character there. Okay, and of course guys, no surprises, it's exactly the same for the square root, okay, which we looked at a little bit earlier. So on the left hand side we have our string concatenation, and then we have our casting, okay, to a string data type of Python having gone to the math library, found the square root, so it's empty.sqrt, which is the square root function, and then it has evaluated the square root of 144. Now, of course, the square root character is contained or has been assigned to the constant s. The constant s is right on the left hand side of our formatting, and that's of course because when we express the square root of a number, that little tick symbol goes on the right on the left hand side, right over on the left hand side as well. Okay, so the little tick there followed by the string version of 144, okay, and then our evaluated bit, which is just here. And as I said earlier guys, I know it looks a little bit peculiar, but it is very often the case, as I mentioned, that even though we are working with an integer data type, let me just remove these boxes to make it a little clearer, even though we are working with, let's just make it, there we go, we start off and we're working with an integer data type. Okay, so you would have thought that the value we get from having done the maths would be 12. Okay, but as I said earlier, the maths library and the maths functions within it will very often return to us the value of the maths as float data types, not integers. Okay, so you should expect to see floats, okay, returned from mathematical functions which are in the math library. Okay guys, so I think we'll draw this video to a close, because otherwise it's going to get quite long. It's probably getting on, I would imagine, for between 15 and 20 minutes. So I will see you again in part 2 of this working with basic maths, and we will pick up from where we left off in this video. So I will see you later.